Hello, everyone. In this video, we're going to look at some characteristics of quadratic functions. So what we have here is a quadratic function that's written in what we call standard form. So for this function, x is our input variable, and we see x appear in the rule on the right. And a, b, and c are some fixed constants. In particular, in order for a function of this form to be a quadratic function, a has to not be equal to 0. So the reason why is because we want that term with the x squared factor to be appearing. If a was equal to 0, then that whole term would cancel out. So a few facts about such functions are the following. So when that a constant is bigger than 0, the function, if we graphed it, has the shape of a parabola that faces upward or is open upward. When a is less than 0 or negative, the shape of the function, or the graph of the function rather, is a parabola that faces downward. Now, a few other features or characteristics of quadratic functions and their graphs is that they all have a vertex. So a vertex is this point where the graph changes from decreasing to increasing or increasing to decreasing. So it's either this peak or this valley in our graph, depending on the shape of the graph. The vertex, when written, or rather a quadratic function, when written in this form, ax squared plus bx plus c, the vertex has a formula or a special formula that we can use to compute it. So the vertex of a quadratic function written in the standard form is the following: negative b over 2a, comma, f of negative b over 2a. So that input value of the vertex is here, negative b over 2a, and then the output is just the output of our function. So f of negative b over 2a. There are many different ways to show and justify this formula for the vertex. We're not going to carry out that work so far or yet in this class. If you do continue with calculus and pre-calc, then you will see that in a future course. But if you do have questions, I'd be happy to talk you through that one-on-one. So please reach out if you do. All right, moving on. One other characteristic of these functions that I want to bring up is the vertical intercept. So the vertical intercept is where our graph crosses the vertical axis. So I'm just drawing some cartoons here, but just to give us a sense of where we can find those values. So one thing about a vertical intercept is it appears or it happens whenever the input or the x value is 0. So the vertical intercept looks like the point 0, comma, f of 0. And now when we are in standard form, conveniently, if we plug in 0 into x, then the ax squared term goes to 0, the bx term goes to 0, and we're just left with c. So in standard form, the vertical intercept is 0, comma, c. But I encourage you to think through these steps when you are finding the vertex or the vertical intercept so that it makes sense why we plug in 0 to find that output. All right, now let's continue with some examples. So first up, we want to find the y-intercept of the function. So up here, we're given a specific quadratic function. That is f of x equals negative 4x squared minus 2x plus 42. Find the y-intercept. So that's the same thing as finding the vertical intercept. So for us, what we need to do is plug in 0 for our x value and compute the f of x value. So that would look like the following. F of 0 equals negative 4 times 0 squared minus 2 times 0 plus 42. So please take a moment and pause the video and try to work that out on your own before continuing. All right, now let's look at it together. So 4 times 0 squared, well, 0 squared is just 0. times -4 gives us a 0. We just have a 0 term there. And then 2 times 0 is also a 0, so we get a 0 term here. So in the end, we just get 42. Now, is our vertical intercept 42? Not quite. Remember that our vertical intercept is a point, so it's a tuple. The input is 0, because that's what we are, or because when we have a vertical intercept, our input is 0. Then our output is 42. So that vertical intercept is 0, 42. Now we want to find the vertex of the function. So recall, the vertex formula is -b over 2a, comma, f of -b over 2a. So let's find what our a and b are. So for our function up here, a is -4, and b is -2. Recall, we need to include those negatives for each term because the standard form has a positive then b value. So we're subtracting, so we include that negative into our a and b constants. So first, let's compute what -b over 2a is for us. We have -2 over 2 times -4. So if we carry out this a little bit further, we're getting -2 over -8. And now -2 over -8, well, those negatives cancel each other out. And further, we can simplify 2 over 8 to become 1 over 4. So we keep that negative hanging out from before. We simplify our 2/8 to be 1/4. And in the end, we get -1/4. So that is our input value of our x value of our vertex. So now let's go ahead and find that output or y value of our vertex. So we need to plug in -1/4 into f in order to compute that output point. So we have -4 times -1/4 squared minus 2 times -1/4 plus 42. So I encourage you to take a moment and pause the video and work out that expression for yourself, and then we'll check our answers. All right, so after doing that work, it's important to really be careful about entering these values in our calculator. Use a lot of parentheses, and I encourage you to also use your Desmos calculator or some other online calculator. But in the end, we should be getting something like 43.5. So what's our answer here? Is this our answer, 43.5? Not quite. So a vertex is an entire point. So we have an input point, which we computed -b over 2a, and an output point, which we computed as f of -b over 2a. So our final solution here is -1/4, comma 43.5, or 43.5 if you'd like. All right, now let's look at part C. So part C says, write the factored form of f of x. And then from there, what are the x-intercepts of the graph? So our hope here is to write f, this function here, as a product. So we want to try to combine some like terms or factor by grouping. So I'm going to start by just rewriting that function so that we have it down here. So we have f of x equals -4x squared minus 2x plus 42. So now a common method of factoring, or rather before I get into that, let's just take a look at this function and see if there's anything that we can factor out of each term, any number. Do we see a common factor of each term? Well, you might notice that each term is even. So that means we can factor out a 2 from each of these terms. And better yet, I'm going to factor out a whole -2 just to get rid of that negative attached to my a constant. So what does that look like? Well, -2 all times, well, my first term will become 2x squared And that's, again, let's just recall, because 2x squared times -2 is -4x, which is the term that I started with. So next up, I'm going to add x, because x times -2 is -2x. Then I have plus 21. That's because 21 times 2, 21 times -2 is -42. So better yet, I actually need to have a -21 there. Good catch if you saw that ahead of me. All right, so now we're going to try to factor this expression here. And so one strategy that we can do is called the AC strategy. So with this strategy, what we do is we try to find factors of the product A times C. So let's go through that to see how that's done. So in this case, my A value is 2, and my C is -2. So 2 times -C is 2 times -21. So together, I get -42. So I want to look for factors of -42 that add together to give me +1. And we're going to see why we want to do this in a bit. So take a moment and pause the video and see what factors of -42 you can find. All right, when you're ready, let's look at some examples. So one thing you'll notice is that 6 times 7 is 42. And better yet, if I have a -6 times a +7, multiply these two terms together, I get -42. What's even better is if I add these terms together, -6 plus 7, I get +1. So I'm going to use -6 and 7 to rewrite my x. From there, we're going to see how we can pull out and factor by grouping. All right, so my next step is I'm just going to rewrite my expression here. But now, rather than just x squared, rather than just x here, I'm going to write minus 6x plus 7x minus 21. So notice I haven't changed my expression at all. If I take -6x plus 7x, I again get positive x. I'm going to erase that for the moment. All right, so now I'm going to look at what I have in chunks. I'm going to look at this first chunk here and notice, is there anything I can factor out of each term? Awesome, I can factor out a 2 from the 2 and the 6. And I can also factor out an x from the x squared and the x. So we're going to factor this as follows. So I have my -2. Put some parentheses here. And now I have 2x times x minus 3. Then we'll notice in these next two terms, I can factor out a 7 from each. And I have plus 7 times, and what do I get but x minus 3. So the beautiful thing happens here. I now have an x minus 3 term in each term in my sum. So I can factor out that term. So I get -2 times, I'll bring out my x minus 3 over here. And then inside here, I still have my 2x and my plus 7. I have 2x plus 7. All right, so our factored form looks like the following. -2 times 2x plus 7, all times x minus 3. And now when you're doing this on your own, it's okay to have these terms in different order. We're just multiplying here, so the order in which we multiply doesn't matter. And if this was a little confusing to you, very understandable. Sometimes factoring can get very tricky. So I just suggest pausing the video, trying it out on your own, maybe rewatching the video, looking for some examples, emailing me for questions. Just continue looking at problems like this, and the more you do, the more comfortable you will be. All right, so what we just did was write the factored form of f of x. Now what we're going to do is find the x-intercepts of the graph. So x-intercepts is where our graph crosses the x-axis. So notice if we have a parabola facing up or down, often we have two of these x-intercepts. Something else we notice about an x-intercept is x-intercepts always occur when the y or output value is equal to 0. So to find those x values that we cross the graph, what we're going to want to do is input or set f of x equal to 0. So let's set that up. So x-intercept occurs when y or f of x is equal to 0. So for us, we're going to set up 0 equals -2 times 2x plus 7 times x minus 3. Now, the reason why we factored f of x to be this product is because whenever we have a product equal to 0, that means one of the terms must equal 0. So if we want to find the solutions, we just set each of these terms in our product equal to 0. So that gives us the following two solutions. So therefore, we have 0 equal to 2x plus 7 and 0 equal to x minus 3. We get two solutions. So let's find what they are. So here, 0 equals 2x plus 7. So to solve for x, I'm going to subtract 7 from both sides. We get -7 equals 2x. And I'm going to divide both sides by 2. So I get x is equal to -3.5. For my second solution here, I'm going to solve for x like I just did in my previous expression. So here, just x minus 3 equals 0, so I can add 3 to both sides. And we're home free. We get x equals +3. So then my two x-intercepts are -3.5, 0 and 3, 0. So how do I know the output values or the y values for each of these points is 0? Well, that's what I started with, right? I set my whole f of x equal to 0. I said, assume the output is 0. What are my x values? Then we solved for x. So my x-intercepts have the x values that we just found and the y values of 0 because that's what we assumed at the beginning. All right, so now let's take a look at these last couple of parts. So the next part says sketch the function. So when we're sketching a function that is a quadratic, there's a few important points that I first want us to draw. And they are the points that we just found. So let's just review. The important points we just found are the y-intercepts, the vertex, and the x-intercepts. So if we look at those three important points, and we have two x-intercepts, so actually 4 important points, we see that the x values, the maximum they go to is about -4 and +4. We see that here, 3 and -3. Those are the largest x values we have. The largest y values get all the way up to 43, 45. So that means that we'll want to put on the x-axis, our scale on the x-axis, rather, will look different than our scale on the vertical axis. So one thing I can do here is start labeling my axes with a scale. I'm just going to use every 2 marks. I'm going to plot another number. So we go from -1, -2, -3, -4. Now the vertical axis is going to be a little bit more tricky because I need to get all the way up to this number here, 43.5. So what I'm going to try is labeling each box as a 5. So 5, 10, 15, 20, 25, 30, 35, 40, and I'm going to make it 45, 50. So the more plotting that you do of graphs, the more familiar this will be of writing out your axes and making a scale. All right, So now what I'd like you to do is pause the video and plot on your own paper those important points: the 2 horizontal intercepts, the single vertical intercept, and the vertex. When you're ready, let's take a look together. So first of all, those x-intercepts, well, I have one sitting here at 3, 1, 2, 3, 0. So I'll plot my point here. I have another one at -3.5, 0. Those are my x-intercepts. My y-intercept is 0, 42, so way up here, about here. And then my vertex rather is -1/4, +43.5. So I go -1/4, really close to that x-intercept here, or that origin rather. And I go all the way up very close to my intercept. So my graph is going to look something like this. And it's going to look a little squished here, and that's just because of our axes labeling. The scale vertically is more compressed than the scale horizontally. So I just want to make a note to that. When sketching, plot x-intercepts, y-intercepts, and it's going to be 1 intercept when we have a quadratic function, and vertex. Then draw the sketch. And from plotting these 3 types of points, you can get an idea of what the graph will look like. Now, should it make sense that our graph opens downward? Well, for us, a is equal to -4. Recall that's just from what we were given in the function. -4 is equal to a. So yes, indeed, our graph should open downward. So check this out. Part E says find the axis of symmetry of the function. So you'll notice that these parabolas, which is the graph of a quadratic function, has a line of symmetry, meaning if I draw a line down that vertex, which for us is a little hard to see, my picture isn't the best, but we see that our vertex, we draw a line through it vertically, and if we folded our paper, our graph over that line, the graph would appear the same on one side as the other side. So we call that line a line of symmetry. So for us, what is the equation of that line? Well, you'll notice this line goes through that vertex, and that vertex has a horizontal value of -1/4. And in fact, every point on this line has an x value of -1/4 because it's just a vertical line. So the equation of the line is x equals -1/4. And so you'll notice that this equation isn't this typical equation y equals mx plus b. That is because, again, we have a vertical line. So for a vertical line, we have an undefined slope, but we write the equation of the vertical line as x equals that x value that every point on our graph has. All right, great work on these notes, everyone.